Hello Mathers. Today this video will cover 2 papers worth of similar materials. So it's easier to just make one video for 2 days and do one upload. I think it saves me a little time that way. So you can just pause this halfway through, or if you're in the mood to do 2 sheets in one day, just keep rolling. But the first sheet I'm looking to explain is the one about expressions. So before we can do any of the board type problems, we'll go through the top 4 answers. So if you can find your 4 answers, your paper, fill in these. So number 1, there's some words that indicate addition. So words that have always meant adding to us if someone tells you a story would be sum, S-U-M, increase, I-N-C-R-E-A-S-E, and the word more. Subtracting is the opposite, so it's the opposite words. There would be the word difference is the answer when we subtract, D-I-F-F-E-R-E-N-C-E, and then it's decrease and less. Instead of increase and more, subtract is decrease and less. Multiply words would be product is the answer when you multiply, P-R-O-D-U-C-T, and then the word of. If you have fractions, decimals, that's where the of comes in. And then quotient is the only divide word we have, Q-U-O-T-I-E-N-T. So what we're looking to do on this paper is do 2 things with expressions. One is first to write an expression from a word phrase that I give you. The other is then to do a thing called evaluating an expression, where I give you a number and you put it into what you made. So the first sample I could do, I could say something to you like 3 more than a number. Well, we need to recognize more was one of our adding words. When I say a number, that's a variable because I didn't say what number it was, so it could be any number. And then I said 3, so we need a 3 in here somewhere. If you're adding, you can add in any order. So if I say 3 more than a number, we could say x plus 3. We could say 3 plus x. Doesn't really matter. I could have come up with this same answer from different phrases other than 3 more than a number. I could have said a number increased by 3, because that's an adding word. I could say the sum of a number and 3. All of those kind of phrasings would have headed me here. If I wanted to do a subtracting example, I could say something like the difference of a number and 3. But for subtracting, we have to be careful because the order matters when we subtract. So if whatever I said first there with the word difference goes first. So the difference of a number and 3 would be that. Or I could say a number decreased by 3. The trickiest one of this family is if I use the phrase less than. If I use the phrase less than, it switches the order of the numbers. So when I said a number decreased by 3, 3 came at the end. If I said the difference of a number and 3, 3 goes at the end. But if I want to use the phrase less than accurately, I'd have to say 3 less than a number. And even though I said the 3 first, the phrase less switches it on you. So this would be 3 less than a number. If I wanted to do a multiply example, I could say something like the product of 3 and a number. Or I could just say, I guess, 3 times a number. Or I could have said a number minus 3 here, or a number plus 3. Those could have worked as well. I could also do, for dividing, something like the quotient of a number and 3. If I say quotient, dividing, the order matters. We have to go in the order that I said. For multiplying, you could go in any order, I suppose, but the number is generally written first. I'm not sure why, but you don't see x3. You see 3x. Or I could do a combination of those things, like 2 more than 3 times a number. So 2 more than 3 times a number. Something like that. The only thing I didn't do was a fraction-y kind of thing. I think there is a fraction one on there somewhere. So maybe if I wanted to do a fraction one, I could say like 2/3 of a number. So then I'd have 2/3 multiplying a number. And just on a quick skim there, I noticed every once in a while I might have mentioned a power. So I could say like a number squared decreased by 3. Maybe we need a power for that. Let me see if I use the word cube. I do have the word cube on this paper. So maybe like the cube of a number increased by 3. I might have something like that going on for the cube of a number increased by 3. One other different one I see on here is the product of two numbers. Well, then I couldn't just do an x, I'd have to pick another letter. So that would be the product of two numbers, or the sum of two numbers, or difference of two numbers. I don't see a lot of that on the paper, but that could be done. Quick skim of the paper to make sure I'm not really missing any ideas. I don't think I am. I think we're in pretty good shape to do this first column. I did these blanks because that's a description of how to do that first column. I'm going to clear these details away because that wasn't my original intention for those to be there. And now what we need to do for the second column is a thing called evaluating the expression, where I'm giving you a number and you just put it in. So if I tell you here that the number I'm giving you is 24, you go back to where you started and just do 24 plus 3 and get 27. We're just replacing the x with the 24. If I told you for this one that x is 11, you just go back here and say 11 minus 3 and come up with 8. If I say x is 10, we go to this, 3 times 10 is 30. If I say x is 12, we go to this, 12 dividing 3 would be 4. If I say x is 5, remember the order of operations, multiply first. 3 times 5 is 15 first, then add the 2, we come up with 17, and that does sheet 1 for writing and then evaluating expressions. I wish you luck on that one. If you don't want to learn more stuff today to do a second sheet today, write down a note to yourself where you are in the video time-wise on the clock and come back another time. Next time you come back, we'd be looking to do a paper on equations. Writing equations is basically the same thing as yesterday's, but the word is will be in the problem, and where you see the word is, you put an equals. So I might say something like 2 more than a number. So like yesterday, more is an add, 2 more than a number, and start with that foundation, is 8. So I put an equals where I said is, and then the 8. So 2 more than a number is 8. I could have also used the word sum, I could have used the word increase. Those would all have created the same sort of category there. I could do something like 4 less than a number. Remember, less than was the subtracting phrase that reversed things. So when I say 4 less than a number, the 4, even though I say it first, it goes second. 4 less than a number is, 10, whatever I want to say. I could have also said a number decreased by 4, or the difference of a number and 4. There's a lot of phrasings that could have made that problem, but that's all the subtract family. I could say maybe something like the product of 3 and a number is 15. So I would do a problem like that. Product means multiply. The product of 3 and a number is 15. To divide, I could do a quotient kind of phrasing. The quotient of a number and 6 is 9. So quotient means divide. Quotient of a number and 6 is 9. That's our setup. Or I could do a longer problem like 3 more than the product of, meaning multiply, 6 and a number is 20. So I said there 3 more than product of 6 and a number is 20. But that's what you're doing in column 1 of this paper on equations through those blanks is make yourself your own equation. I didn't do any powers today, didn't do any fractions today. Doesn't look like there's anything too exotic beyond what I just covered. And then once you establish those problems, we just want to do the opposites. Again, like the equations like the scale, whatever we do to one side, we'll do to the other. Whatever the variable's doing, we'll do the opposite, that kind of thing. So since we see an add 2, we want to subtract 2. 8 minus 2, we get a 6. If if you want to check that, 2 plus 6 is indeed 8, that's checkable. If it's a subtracting problem, do the opposite to add. If we add 4s both ways there, to get rid of the 4s, we would come up with a 14, because 10 plus 4 is 14, and that's checkable. 14 minus 4 is 10. If the problem's going to multiply, you'd have to divide. Cancel the 3's. 15 dividing 3 is 5, checkable, because 3 times 5 is 15. Dividing makes us multiply. To get rid of divide, we multiply. 9 times 6 is 54, checking. 54 dividing 6 is 9. And when you get the two-step ones, remember you have to add or subtract first. Save the multiply or divide for later. So since I see an add 3, I'll subtract 3. Not from this, but from the other side of the equals to come out with a 17. 6x is still just sitting there to equal 17. And then if we divide by 6 to get rid of the 6's, it doesn't go as nicely as this one did. 15 divide 3 worked really evenly and nicely. 6 into 17 won't go evenly, but it does go in twice. If you take 6 into 17, twice gets you a 12. With the remainder of 5, there's multiple choices you can do with that. The simplest being make a fraction, the remainder of 5 on the top, put a 6 on the bottom, and that would cover those. I'll do a little bit of sign variation just in case. If I did one negative on a multiply problem, when we divide with one of each, that would turn out to be a negative. But if both numbers were negative, 2 negatives dividing would have made it positive anyway. Now, multiply and divide both follow those same rules. If I made this be a negative 8, if we were subtracting 2 from negative 8, be careful about that. Subtracting 2 from negative 8, we'd be all the way down to negative 10. That's one of those subtracting problems, like you're already negative, you're going down some more, negative 8 outside temperature, subtract 2 more degrees, it's negative 10, that kind of thing. If this were a negative and we start adding with negatives, the rule for adding when they're different is that it depends on the bigger number, which is the negative 10 right now, the way I recreated that. And we subtract to get negative 6. Some of those things are still alive on this page, but that should get you through the equation page. Best wishes, stay healthy. See you later, everybody.